All right, your torque transmitter, torque differential transmitter, and torque receiver system operation addition. All right, we're recording. Frequently, it's necessary to set up the torque transmitter with the torque differential transmitter, torque receiver, the system of the addition of the reversing the state 1 and the state 3 of the leave of the torque transmitter with the torque differential transmitter with the rotor 1 and rotor 3 leave between the torque differential transmitter with the torque receiver with those connections with the system we have the illustrated figure 121 with the conservative half with the torque transmitter with the rotor is termed with the 75 degree of the torque differential transmitter with the 7 0 degree view with the A with the in the transmitter with the torque transmitter with the rotor 75 degree with the increase of the coupling between the rotor and the chamber 1 with the increase of the current and the consequently the magnetic field around that coil at the same time with the field strength with the stator 1 and stator 3 the decrease of the proportional with the couple the result of the field with the transmitter torque transmitter with the state with the rotate with the counterclockwise line itself with the rotor field with the system that is not connected with the increase of the current with the stator 1 with the transmitter 1 torque transmitter for 1 followed with the stator 3 with the torque differential transmitter that decreases the current flow with the stator 1 and stator 3 therefore the torque differential transmitter the resultant stator field the shift is 75 degrees counterclockwise before with the stronger field with the stator 3 with the center of the rotor of the torque differential transmitter that is in 0 degree of the voltage of the rotor is not changed with a single path with the torque transmitter torque receiver. Remember the rotor 1 and rotor 3 leave with the torque differential transmitter. The torque receiver that has also reverse the justice sample with the torque transmitter with the torque receiver. The system of the stator 1 and stator 3 is interchange. The torque is involved in torque resistance with the term for the rotation rotor in the direction opposite with the rotation torque differential resistance made of the torque field. Therefore the torque receiver the rotate for the standard 75 degrees counterclockwise along with itself with the torque transmitter with us for the torque transmitter with the torque differential transmitter with the torque receiver the system connected with the additional behalf of the same way with the system connected with the subtraction along with the torque differential transmitter rotor remains 0 degree with the condition exit for the torque receiver the rotor file with the torque transmitter rotor exactly as you can see with the system view A is solved the equation 75 degrees 0 degrees 75 degrees 0 the stator 1 rotor 2 the 75 degrees stator 3 torque transmitter runs into the stator 1 stator from torque transmitter for the torque stator 3 goes to stator 1 and torque transmitter from the torque transmitter for the stator 1 goes to stator 3 and the torque differential transmitter stator 2 goes from 75 degree angle from torque transmitter to the torque differential transmitter stator 2 rotor 1 and rotor 2 are at 75 degrees rotor 2 from stator number 2 with the torque differential transmitter where it goes to stator 2 with the rotor 1 and 2 with the 70 both torque differential transmitter with the 75 degree for the torque receiver rotor 1 from torque differential transmitter that goes to stator 3 with the torque receiver the 75 degrees and that's the torque transmitter, the torque receiver, the system operation addition. Torque transmitter, the torque receiver, the system operation. You have the 75 degree angle between stator 2 and the resistor 1 and the stator 3 transmitter. Stator 3 goes to stator 1 and torque differential transmitter for the stator 1 goes to torque transmitter, the stator 1 goes to stator 3 and the torque differential transmitter. Stator 2 has a 75 degree angle with a resistor 1 and resistor 2 from torque differential transmitter that goes to stator 2 with a in the torque receiver, the resistor 1 from torque differential transmitter that goes to stator 3 at a 105 degree angle with a resistor rotor 1 and rotor 2 and stator 3 from the torque transmitter goes to stator 1 on the torque receiver. Now that the torque transmitter with the same position for the torque 75 degree, the torque differential transmitter is 30 degree for the angle between the torque differential transmitter with the stator field with the resistor rotor with the increase of the 30 degree with the appear with the torque receiver with the addition with the rotation torque differential transmitter with the stator field with the transmitter the torque transmitter with the signal with the torque receiver the torque differential transmitter they have at the moment of the own rotor to the own has its term with the torque receiver rotor has now turns 105 degrees. The equation is 75 plus 30 equals 100. 5 degrees solved. Torque transmitter with the torque differential receiver, the torque transmitter system operation subtraction. As previously explained, the differential receiver, the difference with the direct with the chiefly with the differential transmitter in the application of the torque differential transmitter. Each of the previous example combines its output with its own input signal from the synchro transmitter to the transmitted sum of the difference of the synchro receiver. The synchro receiver is provided with the system's mechanical output with the differential receiver is used with the torque differential receiver that provides with the system mechanical output. The output is usually sum of the difference of the electrical signals received with the two synchro transmitter. Figure 122 shows that consisting of the two torque transmitters, number 1 and number 2, the torque differential receiver connected with the subtraction. Torque transmitter, torque differential receiver, the torque transmitter. Number 1 torque transmitter has a rotor 1 and rotor 2 at 75 degrees to 70 the stator 2. Your torque stator 2 goes to stator 2, and the torque differential receiver degree is 45 degrees. All right, rotor 2 goes to stator 2 of the torque transmitter number 2 at 30 degrees. All right, number 1 torque transmitter stator 3 goes to stator 3 of the torque differential receiver at 45 degrees, and torque transmitter stator 1 goes to stator 1 at the torque differential receiver. The torque differential receiver rotor 1 winding goes to stator number 3, and the torque transmitter and resistor rotor 1 from torque differential receiver goes to stator 1. All right, and then the figure is signal with the torque transmitter with the number 1 rotate with the result of the total torque differential receiver the stator field with a 75 degrees, and in a similar manner with the signal with the torque transmitter number 2 rotates relevant in the torque differential receiver the field with a counterclockwise 30 degrees. Since the two resonant field are not rotated equal amount of the torque is exerted by the rotor being with the two field of the line with the torque out with the rotor with the term with the 45 degree with the point with the two field of the alignment, and to bring with the two field of the line with the torque differential receiver. Receiving rotor needs only through the angle of the equal of the difference between the signal supply with the torque transmitter. For the torque transmitter, the torque differential receiver, the torque transmitter system operation addition is set with the previous system in addition with the necessary to receive. It's necessary to reverse. Reverse only rotor 1 and rotor 3 leave with between the torque differential receiver and the torque transmitter number 2 with these connections reverse. The system operates as shown in figure 123. All right, torque transmitter number 1, you have the rotor 1, rotor 2 going in a 75 degree angle between 73 and stator 1, 3 and the stator 2 with the stator 3 of the torque transmitter goes to stator 3 of the torque differential receiver, then stator 1 goes to the stator 1 of the torque differential receiver. The angles between is 105 degrees from resonant field, stator field, 75 degrees, rotor field, 30 degrees. Rotor 2 goes to stator 2, rotor 1 goes to stator 3, and rotor 3 goes to stator 1 of the torque transmitter number 2. Rotor 1 and rotor 2 of the torque transmitter number 2 is at 30 degrees. Assume the torque differential receiver that is initially with a 0 degree of the torque transmitter. The number 1 is turned in 75 degree of the torque transmitter. Rotor 2 of the number is turned with a 30 degree of the torque differential state of the field still rotates at counterclockwise 75 degrees. We call it with the rotor 1 and rotor 3 of the torque differential receiver of the reverse of the rotator field with a 30 degrees clockwise with the angle of displacement of the two fields within with respect of each other. The sum of the signals transmitted with the torque transmitted of the magnetic force pulling through the torque differential receiver the rotor fold. Field with alignment with the state of the torque differential receiver, the rotor of 105 degrees. Therefore, the system solved the equation at 75 degrees plus 30 degrees equals 105 degrees. Your control synchro system. Then should be clear with you, but they form with the discussion of the torque synchro system. They produce with a relatively small mechanical output, but they are suitable only for the very light load. Even with the torque with the system is moderately loaded, is never entirely accurate with the receiver that rotates required with a slight with the amount with the torque overcome with the static friction with a large amount with the power with a 5 degree accuracy they require with the movement of the heavy radar attending with the gun turns for the torque system synchro the given the way of the use of the control synchro of the control system and shift the value of themselves the control cannot move with heavy loads. However, they use the control of the servo system with the do the actual move of the servo system covered in the depth of the next chapter of this module. There are 3 types of control servo synchro of the control transmitter, the control transformer, the control differential transmitter, the control transmitter with the control differential transmitter and identical with the transformer transmitter with the I believe torque transmitter and the torque differential transmitter with the discussed previously is able to hide impedance with the winding with the control and transmitter the control differential transmitter higher impedance winding with the necessary because of the control system the base on the having the internal voltage with the provided with the output voltage with the drive with the large load torque system on the other hand based on having the internal code control provided with the direct current torque needed with the position of the indicator since the way to discover the theory of the operation of the torque transmitter the torque differential transmitter. They explain, but they will not discover the parts of the control transmitter with the control differential transmitter. However, we will cover over the third control synchro of the control transformer in depth during the discussion. Control transformer. The control transformer is just with the name of the implied with the control synchro of the device actually governing the sum of the power amplifying device. You with the power move heavy equipment. The figure 120 shows the fan of view with the typical Counter transformer and schematic symbol. The stator winding, the drum rotor, and the slip rings. Rotor 1, rotor 2, stator 1, stator 2, stator 3 on the outside. Show the stator 1, stator 2, and stator 3 on the outside circle. Rotor 1 and rotor 2 at 0 degree of the adjustment, pointing at stator 2 at 0 degrees. The control transformers compared with the two signal of the electrical signal applied with the share of the mechanical signal applied with the row of the output of the different signal of the control of the power and amplifying of the device unless everything of the equipment. Unit control with the physical character of the control train they were similar to the control train with the torque receiver the shaft with the nose amp of the rotor with the arm of the round with the rotor rather than the silent pole rotor. The interesting point of the rotor that is never connected with the AC supply, therefore the induced no voltage with the stator core with the result of the control transformer the stator current with the determinant slowly by with the voltage applied with the higher impedance of the stator winding. Rotor itself the winding with the nose position have a very little effect with the stator current with the also the never any of the applicable appreciable the current flowing with the rotor with the big the old output voltage is always applied with the high impedance load as a result of the control transformer. The rotor does not charge the valve with the magnetic field of the stator that must be turned by the sum of the external force. The stator winding with the control transformer, the consider with the primary winding with the rotor winding with the secondary winding with the output with the take of the rotor 1 and rotor 2 with the rotor lead with the voltage with the include and do for the rotor winding with the phase with the amplitude with the output voltage depending with the angular position of the rotor with respect to the magnetic stator. Our control synchronizing system and operation for the control synchronizing system with the control chain with the control chain with the illustrating the figure 120 with the stator winding with the control transmitter with the connected with the stator winding with the control transformer. Both of the synchros are shown at the 0 degree. Note for the 0 degree for the control transformer with the rotor with the perpendicular with the stator 2. This is the control train with the power with the synchronizing with the adjusted power with the peculiarity of the control transformer with the rotor with the control transmitter with the 0 degree with the rotor magnetic field points straight up and shown with the black arrow. The voltage induced with the control transmitter with the stator is winding with the result of the field with the impress with the control transformer the stator winding thus 3 lead with the connecting the stator 1, stator 2, and stator 3 terminal with the exciting for the current proportional with the voltage flow with the control transformer stator winding itself with the magnetic field with the controller transformer the same with the direction with the white air with the magnetic field with the black air with the control transmitter with the observer with the rotor with the control transformer is perpendicular to the stator magnetic field, therefore inducing the voltage of the rotor field rotor 0 as indicated with the straight line or oscillope presentation. Alright, this shows the AC voltage at the controller transmitter resistor rotor 1 and rotor 2, the induced voltage at control transformer the resistor rotor 1 and resistor 2. The arrow goes up to pointing 0 at rotor 1 and rotor 2 to 115 degrees at stator 2. The stator 2 goes to 0 degrees at control transformer. Rotor 1 and rotor 2 is at 0 volts, and control transmitter is connected to the control transmitter and transformer. Stator 3, stator 1 from the control transmitter is hooking up the stator 1 of the control transformer. Alright, here when the control transformer is rotated down with the gears and shown figure 126 with the rotor is a pair with the resonance stator with the field with the maximum magnetic field with coupling and curve between with the rotor and stator field with at this point with the result of the coupling and stator winding with an induced for the maximum of the 55 volts with the rotor winding with the phase of the voltage dependent directly and with the control transformer the voltage with the turn the rotor voltage control transformer to the driven cell with the clockwise rotation stator magnetic field with the induced for the voltage across the rotor with the proportional amount with the rotation in favor of the AC supply voltage with the counterclockwise rotation with the stator magnetic field produced a voltage that is still proportional to the amount of the rotation about 180 degrees out of 5 favor of the supply voltage with the keep in mind with the clockwise rotate for the counter transformer. Stator magnetic field is in the same with the counterclockwise with the rotation of the counter transformer. The relationship between the AC supply with the voltage of the counter transformer output voltage becomes the more apparent with the figure 127. AC voltage with the control transformer with the rotor 1 and the rotor 2. The induced voltage with the control transformer with the resistor rotor 1 and rotor 2. Stator 2 and stator 2. Control transmitter with the 0 degree with the rotor 1 and rotor 2 to 115 degrees is 0 degree with the stator 2 goes to stator 2 with 90 degrees with the rotor 1 and rotor 2 at 55 degrees. Both stator 3 and the control transmitter is connected to the control transformer stator 3, stator 1 from the control transmitter with connected to the control transformer stator 1. Alright, mechanical input. The control transmitter of the control synchro system is the control transmitter of the control transformer. The mechanical input goes to the control transmitter of the control transformer. The error signal goes to the amplifier, motor, and load. And its mechanical response goes back to the control transformer. This shows the AC voltage of the resistor 1 and resistor 2 with 115 volts at 60 degrees between stator 2 and stator 3. Stator 2 goes to stator 2. And also 60 degrees between the control transformer and control transmitter. are both at 60 degrees, holding 60 and 0 degree angles, induced voltage. Resistor 1, stator 3, at the control transmitter with the control. Stator 1 of the control is connected to the control transmitter with the control transformer. Stator 1. All right, 6 degrees of the AC voltage supply with the rotor 1 and rotor 2 is at 160 degree angle of the control transformer with the stator 2 with the go of the stator 2 with over the control transformers. They also at a 60 degree angle with the show of the rotor 1 and rotor 2 and induced voltage is straight. Stator 2, stator 3 of the control transformer the control transformer and transmitter is connected with the control transformer, and the stator 1 is connected to the stator 1 transmitter. When the rotor with the control transformer is with the A with the figure 127 with the turn of the 60 clockwise with the magnetic field with the counter transformer with the black air with the magnetic field with the counter transformer with the white air with the rotate with the 60 degrees clockwise with the action. And due to the voltage control transformer in the favor of the AC with the supply with the indicator with the oscilloscope with the presentation over the control transformer with the VB with the turn with the 60 degrees counterclockwise direction with the 0 degree with the position magnetic field with the white air with the control transformer. Also rotates counterclockwise with the same with the number of the degree with the counter transmission counter transmitter with the sense of the magnetic field with the shape of the counter transformer that cuts with the rotor with the opposite of the direction and this is the voltage with the down out of the AC supply with the controller transmitter. The show of the outlet slow presentation it's necessary with the become the control transformer with the control servos so they have the control transformer the reduce the zero with the prevent any further movement of the load accomplish the necessary to bring the rotor with the control transformer through the same number of degrees in the same direction with the rotor with the control transmitter. This play for the control transformer with the rotor perpendicular with the own stator field with the reduce the output voltage 0 volt induced in view C. With the counter transformer output voltage discussed throughout this section is commonly referred to with the arrow signal. This is because of the voltage of the repetitive of the man with the direction of the counter transmitter with the counter transformer with the rotors or out of the corresponding with the arrows, the signal of the eventually is you with the moving of the load with a typical servo system now that is covered with the basic operation control system Synchros. And let's see how the system works with the servo system with the move. They have the equipment, the figure 128 show of the block diagram of the typical servo system, the control synchro system. They assume with the shaft of the control transmitter with the system. They determine by some mechanical input with the cover the arrow signal with the generator with the control transformer to cover the control transmitter with the control transformer rotate rotor. Now the corresponding with the arrow signal to amplify the servo amplifier applied with the servo mirror of the servo motor. Turn the load throughout the mechanical linkage cover the response, but also turn with the rotor with the control transformer. The servo motor turn by the rotor with the control transformer so that it's once again with the corresponding with the rotor with the control transmitter with the arrow single drop with the 0 volts of the system comes to a stop. Mechanical input with the control transmitter with the control synchro system with the control transformer. The arrow signal to go the amp of the motor and load. The load goes that mechanical response from the load goes back to the control transformer. Synchro capacitors, as well as the early shape of the speed, of the accuracy of the transmission. Most importantly, with the more complex synchro, with the differential control transformer, the accuracy of the synchro with the system must be effective. The following discussion will deal with how complex synchro is effective with the accuracy with the synchro system. That we can what can be done with the accuracy with the high as possible. The synchro with the capacity to play a major role with the maintaining with a higher degree with the accuracy with the synchro system. We're going to torque transmitter the connect with the torque receiver, the torque transmitter with the torque receiver, the very level of anything with the current flow with the shape of the rotor with the corresponding with the basic of the voltage with the due for the the torque receiver the winding with the most actually balanced voltage over the for the transmitter with the winding with the torque receiver that is vary with the sense for the small changes in position with the torque transmitter with the cover with the torque receiver that is foul with the torque transmitter with the high transmitter with a high degree of accuracy. When the synchro system contains with the differential of the synchro with the torque differential transmitter and the control differential transmitter the stator current with the corresponding with the greater that they are air and synchro with the torque transmitter with the torque receiver. These reasons set up the turns ratio between the state of the rotor with a different synchro. In synchro system, the U for the control transformer with the stator current with lines with the corresponding with the also agree with the torque transmitter, the torque receiver, the system. In this case, out with the reach for the control tank receiver, the transformer with the rotor with the not energized with the result no voltage with the induced with the state of the opposite with the voltage with the transmitter. State of the over effectively of the increase of the state of the current to reduce the accuracy of the system to maintain the higher accuracy of the synchro system to contain the other differential of the control transformer the state of current to be kept in the minimum of this system to connect with the synchro capacitors in the circuit. To understand the operation of the synchro capacitor, how they reduce the current with the drain with the transmitter with the recollection with the voltage current relationship with the inductive with the capacity of the circuit as you've learned with the miles joule and series the current lags with the voltage with the WI 90 degree of the Pearly. Is in a Pearly inductive circuit that you also know the ideal inductor is impossible to make with the cover. There is always a resistance in practice, therefore the inductor with the combination of the inductance, the reactance, and the resistance and the current with the voltages are always favor the resisting current circuit of the 90 degrees out favor the inductive current. We say that there are two currents with the inductor loss current with the resistive in phase current and the magnetic current with the inductive out favor the current with the magnetic current with like to eliminate with the core with the torque differential transmitter the control differential transmitter the control transformer that makes up the most of the line current. Keep in mind that the current leaves the voltage of the 90 degree with the capacity of the circuit. Let's see what happens to the magnetite with the current with the capacitor is the head of the circuit. Suppose with the capacitor is hooked up with the stator coil with the torque differential transmitter with the capacitance with the drive of the resistance equal to the resistance of the reactance with the coil. The two reactants are equal. The current with the draw with the most of the equal. Be all with equal. However, the currents are going to be with the 180 degrees out of phase because of the current with the coil leg with the line voltage with the capacitor currently with the distance of the two currents that are equal to magnitude both in favor of the cancel the total line current. They're reduced by this effect. If the capacitor replaces the current with each of the coil, the torque differential transmitter with the line with the current decrease even for the effect with the increase of the torque of the synchronous system near the point of the corresponding, therefore increasing overall accuracy. Overall system accuracy. Connecting the capacitor across the individual stator with the winding with the impractical with the receive required with the stator winding with the common connection with the outside with the synchronous. If this is not done with the synchronous, none of the rest of the head to vibe with the connect with the capacitor with the work is just as well. This is mentioned shown in figure 129. Show the two stator. These are all show the three a triangle with synchro capacitors and stator each sign from stator 2 to stator 1 to stator 3. The three delta-connected capacitors shown in figure 129 usually come with a unit mounted in the case of the third external connection. But the entire unit of the synchro capacitor is made by the many side with the requirement to all side with the standard differential control and transfer with the synchronized capacitor array with the total capacity the sum of the individual capacitor over the unit. The figure 130 shows the synchronous capacitor with the effect of the operation for the control system. And in this, the figure of the capacitors play for the control transmitter with the control transformer with the two current meters for the display for the circuit to show the effect of the capacitor with the heads on the stator current with the meter connected to the between the capacitor with the control transformer. The reads normally stay with the current 32 milliamp of the current normally flows into the stator with the control transmitter. The synchronizing capacitor will not be connected with the other meter with a reading of 10 milliamperes. It is left out with the original stator current with the magnetizing current that has been canceled without with the synchro capacitor by reducing the current drain with the transmitter with the sensitivity and accuracy of the system increases. Or show the resistor 1 and resistor 2 on the inside with the coil of the control transmitter, the stator 1 and stator 2 with the 10 milliamperes and 30, in between the synchro capacitors with 32 millimeters for the amp of the stator 1 and stator 2 and the stator 3, the control transformer, the resistor rotor 1 and rotor 2. Alright, figure 131, show the another application for the synchro capacitor for the time differential shift of the circuit capacitor between the place of the torque transmitter with the torque differential transmitter with the meter of the reading with the same of the comparison between the current for the previous paragraph. The only significant difference between the circuit is on one of the figure 130, the differential draw of the more stator current within the control transformer. Figure 131 show the use of the synchro capacitor, the total differential transmitter with the torque transmitter with the rotor 1 and rotor 2 with the stator 1 with stator 1 and 2. There's 0.15 amps through the synchro capacitor with on stator 2 with the stator 2, and then goes to 0.6 amps on stator 2 of the TDK. Rotor 1 and rotor 2 of the TD torque differential capacitor. Rotor 1 and rotor 2 with the 0.1 amperes to the total stator 1 and stator 2 with the outside of the torque receiver. Rotor 1 and rotor 2 goes to rotor 1 and rotor 2 torque transmitter 115 volts to 60 hertz. Some synchro systems contain the differential control transformer. The illustrated figure 132 with the figure with the larger state of the current flow with the control transmitter. Since they apply with the loss of the voltage as well with the magnetism of the current, both the synchro the 2 meter with the play for the sugar to show with the state of the current of the control differential transmitter, the control transformer, and another meter with the display for the series of the excitation voltage with the shift over the amount of the current being drawn from the AC line with 0.9 amperes. 0.9 amperes of rotor 1 at 60 hertz and rotor 2 with the control transmitter with the 0 to 0. Stator 1 and stator 2 and stator 3. From the control transmitter with the control differential transmitter, stator 2 has 0.62 amps with stator 2 to stator 2. Control differential transmitter, rotor 1, rotor 2, and rotor 3 go to stator 1, stator 1, stator 1, and stator 2, stator 3 of the control transformer. The rotor 1, 2 from control differential transmitter, the control transformer is 0.4 amps. The rotor in 1 and rotor 2 is the output on the control transformer. Adding synchro capacitors shown in figure 133 with a greatly reduced the stator comparison to improve the efficiency of the LC system. I'll note that the line current with reduced is 0.9 amperes for the figure 132 is 0.65 amps in figure 133. Alright, you get 0.65 amperes in resistor ammeter with rotor 1 and rotor 2 with 115 volts, 60 hertz. The control transmitter with the stator 1 and stator 2 and stator 3 go through the control Differential transmitter synchronizing capacitor. Stator 2 has 115 amps and goes to stator 2 through the control differential transmitter. The synchro capacitor is 0.625 amps to the control differential transmitter. Control differential transmitter, rotor 1, 2, and 3 go to the control transformer, synchronizing capacitor, stator 1 and stator 2, stator 3 with the control transformer. Control differential transmitter with the milliampere of 1/100th of the amp go through the control transformer, synchronizing capacitor at 0.04 amps, and the control transformers, rotor 1 and rotor 2 are the output. Alright, when you synchronize capacitor, you will always be play physically current flow with the differential control of the transformer with the current is correct. With this is done by the connection with the shortest possible to give with the high current along with the heat with the increase with the transmitter with the reduce the accuracy of this system. When we must travel the synchro kind of capacitor should never be with the simple transmitters receive with the system and they become with the stator current with the system on a zero corresponding with the addition with the synchronizing capacitor would only increase the stator current with the system without a balance. Multi-speed synchro system. The data is transmitted with another important factor that we consider the discovery the accuracy of the synchro system. The data covers with a wide range of the data with the basic synchronizing system. It's unable to detect any small change of the data with which happens to the accuracy of the system and the degree of the difficulty in multi-speed synchro system where develop the handles type of the data very effectively and still maintain with a higher degree of accuracy. Multi-speed synchro system and use the more than one speed with the data transmitted. The speed of the data with the transmission simply number the line with the synchro transmitter. The rotor must be determined to transmit the full range of value. For example, the system in which with the rotor synchronous device with the determine with the unison with the input with the output with the shelf with the commonly called with the one speed with the data with the transmission speed. In this system, the transmitter rotor is geared with the one revolution of the rotor corresponding one revolution of the input. With until now, the description of the discussion synchronizing system has dealt with exclusively one speed system. And 36 speed with the data transmission, the rotor synchro transmitter gear leaves to determine through the 36th revolution of one revolution input with the unit transmits the data one speed with the frequently called 1/3 speed with synchronizing the unit transmitting the D. Data is 36 speed with 36 speed synchro and so forth. Things quite with the same common with the synchro system. The transmit the same data with the two differential speed for the example ship course for the information usually transmit with the other locations on the speed of 1 to 36 speed with the system which with the data with the transmit with the two differential speed with the call with the dual and double the speed with the system. Sometimes the double speed will be referred to with the by speed involved with the figure 1 and 36 speed. But then some of the speed data transmission referred to the 1 speed, 2 speed, 36 speed, and some of the other different numerical ratios. Identification number of the different speed with the data is transmitted with the referred to the system of the single speed, the data dual speed, and the tri-speed synchro systems. Single speed synchro system. And the data with the transmit with the curve of a small range of the value of the single speed with the system and normally accurate enough for the over the application with the data covered the wide range of the value with the accuracy with the system is more important than one speed system with not added quick enough must be replaced by a most suitable system and increase the speed with the single system with one speed with the 36 speed with the provide with a greater accuracy self-synchronizing feature with the one speed system is lost. The primary power is interrupted with the 36 speed system with the transmit with the term with the before the power with the reply with the synchro system complying with the realigning themselves in the area's position, the number of the position and the which the transmitter receiver the report is corresponding to the same with the transmission speed with us the 36 speed, but therefore 35 incorrect position, only one correct position of the corresponding for the accurate transmit of the data over the wide range of the value without the loss of the level synchronizing the operation. Multi-speed synchro services must be used with the multi-speed synchro services used with more than one of the speed of the data of the transmission, therefore they require them more than one output shaft. Are your dual speed synchronizing system to basic dual speed synchronizing system give the for the transmitter to receive the shown figure with 132 with the 134 with the one transistor receive the external input of the system with the network with the Gyros path with the effect of the external input with the secondary transmitter the gear ratio with the two transmitter the determine the two speed system of the speed system will use the transmitter with the input of the data with the two speed with this system are referred to the fast and slow high low with the more often defined course. 134 with the dual speed synchro systems. The course transmitter is the rotor 1 and rotor 2 with the stator 1, stator 2, 1, stator 3. Input shaft with the fine transmitter with the stator 1, stator 1, stator 2, and the stator 3. 115 volt 60 vertical volt state rotor 1, rotor 1 and rotor 2, and rotor 1 and rotor 2 on the input shaft with the fine transmitter with the course transmitter. Stator 1 and stator 2 and stator 3 of the fine transmitter go over the fine receiver. Rotor 1 and rotor 2 of the are both connected to the course transmitter, fine and Mr. rotors, and over the fine receiver and then course receivers. You have your dials on your stator and your fine receiver, the course receiver, the stator 1 and stator 2. In this example, the gear ratio between the transmitter is 36 to 1 with the one revolution of the rotor with the fine transmitter, with the 36 revolution of the rotor with the second transmitter with the force transmitter. This is the one with the except for the external input with the can be coupled with the coarse transmit with the second with the one coupled with the fine transmit with the representative with the speed with the include with the 1 and 36 with the 2 and 36 with the 2 and 72 with the output with each with the transmit with the base. Pass through the standard Synchros connection with the receiver, the one with the receiver, the receiver with the core signal with the other, the one with the receiver, the fine with the two receiver, the main with the may not be connected with the network gear, similar to the network between the transmitter and some of the dual speed applicable for the double receiver, the individual receiver. The double receiver, the figure 135 with the consistent of the course and final receiver that includes in a common housing of the two shaft output with the inside with the other course with the fine receiver that may be like on the hour of the minute hand with the clock with the other course receiver the corresponding to the on the hour hand of the fine receiver corresponding to the minute hand with the double receiver the hand for the requiring less space for the two the signal receiver the hour with the disadvantage of the one receiver that go bad both must replace. This showed the cutaway with the U double the receiver the have the damper the terminals the brush caps and the input shaft the out shaft double ampers stator lamination stator pole rotor. And dual speed synchro systems of the data is transmitted, the course transmitted with the system of the fire outside with the corresponding with the shift of the fuel transmit, fine transmitted with the system approach with the corresponding with the shifting of the core with the fine control done automatic with the fine arrow signal with the receive of the course arrow signal with the fine synchro transmit with the drive of the system with the point with the corresponding. When the dual speed synchro system include with the core control transformer, the always possibility of the 180 degrees arrow being for the present with the system, the region for the rotor with the control transformer with the energy drive of the arrow voltage with the output with the zero, but in the proper position, I also point with the 180 degrees out of the way. From the position to prevent the counter transformer from locking the 180 degrees for the phase rest of the system and the low voltage supply with the cross of the rotor terminal of the control transformer that's shown in figure 136. Figure 136 with the dual speed synchro system. You see with the stick off the transformer. You get the fine cut control transformer going to rotor going it to synchronizing control CKFT amp motor load and winding. The control course control transformer, 115 volts stick off transformer, 2.5 volts grounded, and fine control transformer rotor shaft grounded. Alright, the voltage is normally about 2.5 volts, commonly called the stick off the voltage obtained with the secondary and small transformer. The voltage is induced by the secondary transformer shift of the zero poles position with the core for the core control transformer of two. The re-establish the new zero position for the state of the core control transformer must be turned through angle induced for the output for the 2.5 volts rotor stake of the cancel for the stick of the voltage of the air 0 voltage is 2 volts with the cancel for the input for the no input except for the drive of the servo amplifier. There should be rotor the control transformer stop at 180 degrees. Same with the 2.5 volts would be induced for the however, there would be in phase with the stick out voltage. No cancellation would occur with the end, but the result of the arrow signal with the 180 degree with the drive of the dual speed synchronizing system out of any false synchronizations. Or your tri-speed synchronizing system. The event of the long-range missile with a high-speed aircraft that has brought with a need for the accurately transmitting the large quantity of the best done by the tri-speed synchronizing system with the transmit tab with the 30 different speed with the speed of the system referred to the course of the medium and intermediate with the defined with the typical weapons. For example, the transmit with the range of the mile thousands of the hour with the hundreds of the hour with the providing with the range of the three different scale with the greater accuracy of the time with would be possible the dual speed representative speed with the tri-speed should the system include 136 and 180 180 136 and 360 118 and 3648. Alright, zeroing synchronizer. The synchronizer are to work with the properly shift that must be connected with the line with correctly with respect to each of the other devices which they are used with the reference point with the line with all synchronizing unit with the electrical zero with the electrical zero. The mechanical reference point with the units connected with the synchronizing dependent on the particular application for the synchronizing system wherever the application electrical mechanical reference point to be in line with each other the mechanical position unit that usually set up with the synchronized device aligned with the electrical zero. The various methods with the zero synchronized with the more common the zeroing method over the voltmeter with the electrical line with the synchronizing test method with the method that depends on the facility and the availables. How the synchronizing are connected within the system, all the method with the variable, the unit with the rotor and stator, they're down freely with the turn away with the different procedure with the varying, similar with the unit with the whose the rotor and stator is free of the turn. The voltmeter, the most accurate method of zeroing with the synchronized with the AC voltage with the method of the producer and with the test curve configuration of the methods vary somewhat with depending upon what the type of the synchronizing is to be zeroed and the transmitter the receiver the differential control transformer each will require the different testing and control circuit configurations. Regardless of the synchronizing, is synchronized to be zero with the two major steps of each with the procedure for the first step, the core for the approximate signal, with the second step of the defined setting, with the core setting of the ensure that the device is zero in zero position rather than the 180 degree of the bank. Of the synchro units might be marked in such a manner the core setting with the band be approximately physically in line with the two marks for the synchro on the standard synchronizer setting, the indicator with the arrow stamped on the frame of the line marked on the shaft that's shown figure 136 with the 7 and with the defined state with the synchronizing is approximately 0. Arrow stamped on the frame, the marking on the shaft, extension, and the course electrical 0 marking. For AC voltage, the method of the accurately possible electronic precision voltmeter have 0 to 250 volts, 0 to 5 volts range. Should be a U. For the low scale, the meter should be also able to measure the voltage for the 0.10 of a volt. All right, zeroing transmitter with the receiver, the voltmeter method. The same for the transformer, torque transmitter with the control transmitter with the torque receiver, the functional, the physical, similar with the zero, with the same with the main with the torque transmitter, control transmitter rapidly with the zero with electrical 0 volt with the stator 1 and 52 volts, with the stator 1 and stator 3 26 volt with the must exist with the cross with the stator 1 with the rotor transmitter with the set 0 with the mechanical the reference point, synchronizing receiver with it's probably 0 with a divided with the actuator, assuming that 0 with the mechanical reference position, electrical 0 with the voltage with the stator 2 with the 52 volts, stator 1 and stator 3 with the 26 volts, exists with the cross of stator 1 with the following step-by-step method procedure of the U with the 0 of the transmitter, torque transmitter, the control transmitter, with the torque receiver, the carefully set with the units with the antenna, with the gun mount, with the director, etc., with the motion position, with the control transmitter, torque transmitter, with exactly 0 degree with the reference point, with the K with the torque, receiver, the de-intercept, with the circle, with the disconnect, with the stator lead, with the before setting, with the rotor on the 0 with the reference point, with the rotor may need to be secured with the position, tape with the dial, with the frame, and the most efficient, the de-intercept, with the synchronizing circle, with the disconnect, with the stator leaves, no, but any of the synchronizing systems are energized with the individual schedule. Switches therefore be to show with the synchronizing power is off the beam, working with the other connection set voltmeter 0 to 250 volt with the connected in the circuit as shown figure A of the figure 138. Alright, figure 0 to 124 volt, the voltmeter, resistor 1, rotor 1 with the on a line with the torque transmitter, control transmitter, and torque receiver. 115 volts or 226 volt for the rotor 1 to go to stator 1 and stator 2, rotor 2 go from to stator 3. Energizing, synchronizing circuit with the turn the state of the until the meter reads with the 37 volt, with the 115 volts or the 26 volts synchronized with the voltmeter reads approximately 193 volts, 115 volts plus 78 volts at 193 volts. The rotor is at 180 degrees. Turn the half a revolution, bring back to 0 degrees. If it cannot be obtained, desired the 37 to 15 volts, you the lowest reading, but you can take it even the meter with the course setting with the this is clear, synchronizing approximately electrical 0. De-energizing can go Synchros to connect with the meter with the shown figure B with the stair with the high scale on the scale with the work down with 0 to 5 volts with the protected with the meter volt movement. 115 volts or 226 volts for the rotor 1 and rotor 2, the torque transmitter with the control transmitter with the torque receiver, stator 1 and stator 2 and stator 3. Stator 1 is 0 to 5 the range from on stator 1 and stator 3 and the voltmeter. Re-energize with the synchronizing circuit with the depth of the stator with the 0 minimizing volt reading. With this is finding the electrical 0 position with the synchronizer. You have connected with the torque transmitter with the torque receiver with the system after zeroing the you can perform simple check on the system seeing if they accurately electrical 0 for the first plate with the transmitter on the 0 of the system and reach for the point for the corresponding into the voltage of the stator 1 and stator 3. Stator 1 even the both synchronizing should be equal to the sum of the terminal stator 1 and stator 3 equal potential. But jumper in between the terminal with the torque receiver that should not affect with the circle with the help of the torque receiver the rotor move when connecting a jump with a slight voltage difference between stator 1 and stator 3. The voltage difference is indicated with the transmitter with not electrical 0 with the K for the recheck with the transmitter electrical 0. Alright, 0 differential synchronizing voltmeter method. Differential synchronizing of the 0 with the wind that can be interpreted with the system introducing any of the chain with the differential synchronizing requiring 0 with the following method voltmeter method. Carefully, accurately, with the set of the unit with those control with the control differential transmitter and the torque and differential transmitter on the transmitter with the 0 on it for the reference point with the K with the torque differential receiver to energize the circuit, disconnect all the leads before the setting the rotor 0 with the reference points, reference position needed to receive the rotor in the position with the tap of the dial with the frame with the usually sufficient. Alright, de-energize with the circuit, disconnect with all the lead with the differential except with the leads of the stator 1 and stator 3 with the U with the 78 volts, the 10.2 volts, and 26 volt unit supply with the transmitting unit with the 0 with the differential, so with the set the voltage 0 to 250 volt scale with the connect with the shown with the view A with the on figure 139 with the 78 volt is not available. The transmitter the form of the auto transformer you may use with the 115 volt source instead of the U with the 150 volts instead of the 78 volts. Do not leave with the asynchronized connect with more than 2 minutes or it will overheat and may become permanently damaged. Alright, this says 78 volts at 2.10 volts are on a two different parallel circuits. The standard the course setting between stator 1 and stator 2 onto the resistor rotor 1, 2, and 3. The stator 2 is on a circuit with the rotor 2 on the torque differential transmitter, the control differential transmitter, torque differential receiver. Alright, you have 78 volts or 10.2 amps on two circuits. Stator 1 and stator 3 would go to rotor 1 and rotor 3 with a 0.5 volt range, and stator 2 goes to the is alone. And so is rotor 2. Total differential transmitter, control differential receiver, total differential receiver. Energize with the circuit unclip with the differential state with the term with the U with the me with the me with the differential now approximately electrical Z with the D energize with the circuit with the reconnect with the show with the view B with the D energize with the circuit with the show with the scale with the me with the work down with the 0 to 5 volts with the scale with the protect meter movement at the same time with the turn with the differential state with until the obtain with the 0 the minimum voltage reading claim with the differential state with the position ensure with the voltage reading does not change with the divine electrical 0 with the position of the differential. Zero control transformer, the voltage to voltmeter method. The two conditions must exist for the control transformer to be on the electrical zero. The first, the rotor voltage with the speed meter when the electrical voltage is stator 2 with the 52 volt with the stator 1 and stator 2, the stator 1 and stator 3 with the 26 volts applied with the shaft with the second with the turning with the shaft with the counter transformer. Slightly with the counterclockwise should be reduced with the voltage across with the rotor to fade with the motor volt of the control transformer, control transmitter, torque transmitter supplying with the existing section of the stator with the zero of the control transformer using 78 volts of the the transformer with the voltmeter method using the following procedure. Set up the mechanism of the drive with the control transformer with the rotor zero with the reference point position with the also set with the transmitter, the control transmitter, torque transmitter connect with the control transformer to zero with the reference position. Check with the ensure with the zero with the volts between the stator 1 and stator 3 and 78 volts between stator 2 and stator 3. If you cannot determine with the voltage, you will need to re-zero with the transmitter. Note that if you cannot use the 78 volt with the transmitter circuit, the auto transformer is not available to be made able to use the 115 volt source with the U with the 108 to 15 volts instead of the 78 volts. Do not energize the control transformer for more than 2 minutes because it will overheat with become more permanently damaged. You energize the circuit connect with the circuit shown with the UA with the figure 140 with the to obtain 78 volts with the quad with the zero with the control transformer. Leave with the stator 1 lead on the disconnected stator 3 lead on the control transformer. Put the stator 2 lead for the control transmitter with the stator 3 with the necessary with the 78 volts exist only between the stator 1 and stator 2 or the stator 2 and stator 3 is probably 0 with the control transmitter. Now energize the circuit with the turn off the stator with the control transformer. Obtain the minimum reading with 250 volt scale with the course with approximately 0 stating with the control transformer. Alright, figure 148 shows the 0 in the control transformer, the 0 metering methods. There's 78 volts, 0, 8 volts, and the control transmitter stator 1, 2, and 3. There's two circuits, stator 3 to rotor 2, and stator 1 to rotor 1. And the control transformer. Alright, your fine settings are stator 1, stator 2, and stator 3 is 78 volts or 10.2 volts. And control transformer, rotor 1 and rotor 2 on 0 to 5 volt range on the voltmeter. Generators right, then the circuit with the reconnect with the stator 1, stator 2, and stator 3 leads back with the original position of the connecting the circuit with the shown view. B with the re-energize with the circuit with the high scale with the meter with the work down the 0 to 5 volt scale with the predicate with the meter move at the same time turn the state with the control transformer with the aim to the 0 with the minimum reading of the meter. Clamp down the control transformer, then ensure with the reading of the does not change with the final electrical 0 position control transformer. 0 multiple speed synchronizing systems. Multi-speed synchronizing systems usually accurately transmit the data, but the synchronizing system must be 0 together with the necessary together with the synchronizing required with the common electrical 0 with the functional property unit. The system appears to establish 0 with the reference position of the unit of the position of the system transmitted and the 0 with the significant synchro with the system with the work down with the least significant example the course synchronized with the medium synchro the final synchro. When the use 0, the synchros consider each of the synchros individual 0 and is accordingly. Electrical lock method. Electrical lock method, although not accurately voltmeter with the parameter until the towel with the fattest method of the 0 synchronized with the help with the method that became U with the lead with the rotor with the unit with the 0 out with the free with the term with the lead connection with the accessible for the region method that you use total torque receiver the became the unit like with the transmitter the torque receiver shaft with the 3 of the turn. 0 synchronized electrical shock lock method of the D and drive the unit with the connect with the leads is shown with the figure 142 41 with apply the power with the synchronizing rotor will take it then quickly snap at its electrical 0 position and lock of the indicating device connected with the synchronizing shaft does not point with the 0 with loosen the synchronizing and the mounting rotate until the 0 position indicator correspond with the electrical 0 with the synchronizing as well as previously stated. You may use 115 volts as a power source instead of 78 volts provided that you do not leave the unit connected more than 2 minutes. 78 volts is 0.25 volts. The rotor 1 going in stator 2 and rotor 2 going in stator 1 and stator 3 of the transmitter control transmitter and torque receiver. All right, your synchro tester. The two types of synchro testers shown in figure 142, view A and view B. Each of them is nothing more than synchronizing receiver with the calibrated dials is mounted. All right, this shows the knob of the setting dial with the calibrated dial and the type of the receiver that the clutch disengage the dial from the knob. Show the calibrated dial with the release button with the knob with the setting device. This tester is usually primarily loaded defective with the synchronizing, although they do provide with a zero synchronizing. They should not rely without the question power with a calibrated dial with a slip with the proper position, sensitive with the dial with a graduated with every 10th degree, with the difficult to read small angle with the accuracy. Therefore, the synchronizing tether method is zero synchronizing the potential less accurate with the nose prescribed. Previously described the torque transmitter with the control transmitter, the torque receiver, the using synchronizing tester, using the following procedure. The synchronizing tester shown in figure 143. 143 shows the zero synchronizing tester, 115 volt with and 26 volt rotor 1 and rotor 2 on the torque transmitter, the control transmitter, torque rectifier, resistor, and torque and the tester. Stator 1 and Stator 2 and Stator 3 is jumped between the control transmitter, the control transistor, control transformer, and the Stator 1 and Stator 2 and Stator 3 of the tester. Alright, set the unit whose position torque transmitter with the control transmitter, the transmitter accuracy of the zero on the reference position, the K, the transistor, receiver, the 7 the 0 of the referencing point, the turn the shape of the synchronizer, the being 0 until the synchro tester dial reads 0, but the synchronizing is now approximately electrically 0. Monetarily, the Stator 1 and Stator 3 is shown, but the synchronizing tester from dial is moved with the Stator 1 is short of the Stator 3, the synchronizing is not 0 with the check of the test dial, the ensure that it does not slip with the test dial head, does not slip with the move of the synchronizing Stator until there is no movement in Stator 1 and Stator 3 are shorted. This is electrical 0 position synchronizing being aligned. Alright, troubleshooting synchronizing system. One of the duties is to keep the synchronizing system the equivalent of the good working with the other, therefore it is essential to become familiar with the detailed synchronizing system maintenance for the repair. Alright, first let's consider some of the more commonly problems with the working with the synchronizing of any widget with any piece of electronic equipment if they work with leave it alone, but do not attempt with the zero with the synchronizing system as already zero with the just because we want to for specific practice. Most often than not, the system will end up more alignment than it was before. Attempted to re-zero with the do not attempt that may take with the synchronizing apart with the even the defect with the synchronizing P with the precision equipment that require the special equipment. The technique for the disassemble should be done only with the qualified technique for the authorized for the repair shop. The synchronizing unlike the electrical power, but it does not also require periodic lubrication. Therefore, never attempt to lube. Synchronize also require careful handling. Never force synchronizing into play for the never use plier with a threaded shaft. With the never force for the gear and into the shaft of the filing. Never the equipment not relate with the synchronizing system with the primary excitation bus. Alright, this will cover the system to show the system of the shorted rotor with the equipment and with the turn in down, but system will check with the good with the equipment is off. The trouble with the synchro system that reaches with the operation with sometime with the usually with the two type of the first interconnection. Synchro wiring often path with the number of the switch with these point with the open shaft with the ground that may appear they will be expected to trace down. The trouble with the army that you can find that you can openly easily check with the community. Continuing between the 2 points, similarly, you can find with the ground, but check with the resistance between the suspected point with the ground, the reading of the zero arm with the reading of the question is ground with the second area. The synchro itself must be difficult. Defective due to the opening with the short winding with the winding of the necessary with the worn subtly in the directly push with the you can do nothing about the defects and except with the replay with the synchro. Trouble the new modified synchronized system that most often become the improper wiring with the misalignment, couple the synchro that's not being zero with the responsible for the with the correcting of the trouble that you check with the improper wiring with the ammeter, make with the point to point with the continuity of the resistance, check with the correct misalignment with the synchro system, and re-zeroing the entire system. Trouble indicator. When trouble with the occur with the electronic insulation with the current with the large number of the synchronous system within that may vary variable. With the trouble with the one particular system sympathized with the main with the personal located with the main point with the trouble of fixing the short with the time and the possible indicators while and locating with the trouble quickly introduce included with the inclement the indicator of usually signal light the mount of the electric certain control board connected with the different synchronizing system the trouble that occur with the synchronizing system located light connected may either light or flash maintenance personnel with identify the defective system the reading of the name and the number of the adjacent light. Single lights indicate with overload condition, blown fluid overload indicators, dual blue plate within the stator circle with the torque synchro system to be covered with the stator with the give of the plater indicates with the mechanical loading with the current due with the current with the rotor. Circle with the one version of the type of the indicator with the shown figure 144 consists of a neon lamp connected with the end of the stator lead with the synchronizing system let the two transform the primary consisting of the few turns with a heavy wire with the series with the two with the stator lead with the secondary consisting of a turn with the fine wire with the R in series of the lamp the turns the rotor ratio with the design with except for the current flow with the stator wire with the neon lamp lights. For example, the difference of the rotor position exceeds 18 degrees for the light lamp indicating that the load on the motor staff is excessive. Alright, this shows an overload stator currents and there's a neon light in the middle. You have two transformer iron core windings between stator 3 and stator 1 and stator 2 goes to transistor on torque transmitter with the torque receiver. Stator 1 goes to stator 1 on torque And it has rotor 1 and rotor 2 at 115 volts torque transmitted torque receiver, rotor 1 and rotor 2, 115 volts. A blown fuse indicates the front panel light within the protective fuse of the shear with the rotor below with the figure 145 show the typical blown fuse indicated the except for the current flow with the rotor with the wiring with the trigger because of the short side of the mechanical overload or use fuse the blow with the neon light across the fuse light. Alright, this shows the neon light with the two fuses of resistor 1 and resistor 2, two neon lights resistor from rotor 1 and resistor 2, a resistor, two from the rotor 1 and rotor 2 fuses. The torque transmitter and stator 1, stator 2, and stator 3. Another type of the blown fuse indicated with a small transformer here with the two identical primary. The secondary connected with the shown figure 146 with the both fuse connected with the equal current of the flow through the primary with the induced normally canceling the volts of the secondary. The fuse below with the induced the volts with just one primary present with the secondary lamp lights. 146 shows the blown fuse indicated with requiring only one lamp. Show the 115 volt with the two transformer iron cores in between them and the fuse. The resistor goes in, is in line with the lamp transformer. Just a minute. Rotor 1 and rotor 2 torque transmitter, stator 1 and stator 2 and stator 3.